I'm Wannes Rosiers. I'm going to guide the conversation today. I'm Head of Customer Success at Conveyor, and together with me today we have Wim Vancuyck, the data lead at Imec, and Kristof, a team lead at Dataminded. I'm going to first give the floor to introduce themselves. So Wim, if apologies, you could once more introduce yourself.
No problem. I'm Wim Vancuyck. I work at Imec for 4 years now. I'm heading the data team in ICT. A lot of people work with data at Imec, but so for the ICT part, I'm responsible for architecture, strategy, projects, that kind of things.
And then, of course, we also have Kristof from Dataminded, and we see each other more often as Conveyor and Dataminded are closely linked to each other. But as well, welcome to Kristof, and if you could introduce yourself.
Yeah, thank you, Wannes. I already did this introduction, so I'm going to make it more shorter now. I'm a tech lead working for Dataminded. My specialization is mostly on building data platforms. I've done this for quite some years. I've worked with companies that have built their own data platforms from scratch, and also with companies that take off-the-shelf solutions. So I hope that I can bring my expertise to the table here as well.
Yeah, and then today we have no slides, so it's just us. If you have any questions, feel free to pop them in the chat. The topic of today, of course, is zooming in why not to build your own data platform, or maybe glue some elements together. We're going to fully focus on Wim's story at Imec, but elaborate on that with a bit broader market knowledge as well, experience from other Dataminded customers by Kristof. But first to you, Wim, if you could just briefly describe a bit the data platform of Imec to set a bit the scene.
Yeah. We have two major parts in our data landscape, and we have the data engineering part, where we rely on Conveyor as the backbone of the data engineering practice. And then we have the data science part, where we have a lot of things. We have various profiles that use data, from Power BI reporting, simple stuff, to notebooks, codes, deep dives, and all kinds of other statistical tooling used by our R&D people. So that's a bit the basis. The data engineering part is in the Azure Data Platform. Conveyor as the glue to bring a lot of Azure components together. It's a lakehouse concept, so we ingest data, we transform it, we write it as structured data in the Delta format in Azure Data Lake Store. We use Spark, Polars, that kind of things for those pipelines. And then we expose the data again, typically through SQL interfaces. So there we're experimenting with the Synapse engine, with Microsoft Fabric, with that kind of things. We also put APIs on top of them now to make the data more easily accessible also in front ends and notebooks. So that's a bit high level what we have.
Yeah, that's kind of a modular approach where you take quite a lot of tools, a bit from the Azure framework, a bit open source Conveyor in there. We're not going to deep dive in why you choose one component. But it's always interesting, I think, to have a bit of the context of your company, why you choose one or the other. So were there already constraints? So at Imec, like preferred cloud provider, more a buy versus build company? Tell us a bit about Imec.
When I came to Imec, Microsoft was already there, so we were already a Microsoft customer, so the choice for Azure was pretty clear. As with all Microsoft products, it's not the absolute best. It's also good enough to work with, so we started with an Azure-based data platform. The approach was rather greenfield, and we had a SaaS data warehouse that did a lot of things, which was the core of the data landscape when I arrived. But the decision was already taken to move away from that. It was an on-prem traditional data warehouse, so we wanted to do something new in the cloud, and we already realized, okay, cloud gives a lot of benefits. And that comes also from a bit the buy versus build mentality in Imec. Imec has grown very fast. Imec is now 40 years. We are with 5,500 people, I think. But IT has never really grown with it. There is a lot of R&D, but IT was 50 people that kept the SAP system alive and the MES system alive. So IT really needed to start growing and scaling to support 5,000 R&Ders that do all kinds of research. So from that perspective, it was not really realistic to build out a team by hiring people. So we buy a lot and we work a lot with partners. So that's from the IT side. Management also asked me, okay, are you building things? Do you really need to build things? Can we buy something also for speed? If you buy something, it's faster. Building always takes some time. So that's the background of Imec and IT and why we typically buy services and products. On the other hand, we have a lot of researchers who are very much used to building things, and they so far didn't get that much support from an IT team. So they're very used to doing their own thing, taking something from the internet, typically open source, something free that they run on their own laptop. So they're very much used to building things, and there have been built a lot of marvelous engineering masterpieces. So it's a very, very diverse buy versus build. We're also a non-profit company, so we don't have huge budgets. So going all in one ecosystem that then is pre-configured is typically rather expensive. So that's why we didn't go for a full SaaS-based continuation. You can buy everything in SaaS pre-integrated, but it's rather expensive. And also we try to avoid lock-in. That's then a more personal thing that I have. I try to avoid major lock-ins with vendors. We're also we're more looking towards the cloud because we see very much that our on-premise infrastructure, there are a couple of people managing that. We do a lot of things on-premise and it works and it's relatively cheap, but it's very hard to scale it. It's very hard to maintain it. It's very hard to do it decent, to get it really secured. I'm assuming it's secured, but so that's that's why we look to the cloud to not reinvent the wheel on premise. Voilà.
Yeah, thanks, Wim. Kristof, I hear Wim talking about the desire to go to cloud, pre-selecting Microsoft. Yet the desire to avoid lock-in. Thank you for the remark, Bart. Some budget constraints, an internal tension between IT willing to buy to speed up, whereas researchers want to build as they're used to it. Are these constraints and cultural things you recognize in other companies?
Like I said, I've been seeing many companies in all colors, shades, and forms, and all they're looking for a data platform. And what I usually see is a kind of three factions always occurring in an organization. You have the IT department, and the IT department is really focused on providing standardization, best practices, tooling for people to make use of. You also have kind of a business department. They usually want to go fast and they want to focus on value and please give me value as much as possible. And then there is also a governance department and they are more legal process minded. They talk about procedures and documentations and signatures and all this kind of stuff. And it's always the interaction between those three factions, you might say, on how the things work in an organization. And I've seen many different reasons why people go for build and buy, and depending on the faction and the strength of those faction and the opinion of that faction, you can have a different build or buy. Like for example, business is very simple. They want to buy. They don't want a platform. They just want something that works. So that's usually very simple. In IT, I've sometimes, I like your pragmatism, Wim, that you said in Imec, we have a tendency to buy. I have seen IT departments that have a tendency to build because they like to build, they have the engineering force, and they believe that they can do this themselves. And then there's also the governance department, and it's also a little bit of a mix there because sometimes they like to buy and take stuff off the shelf. But if they're a very strong governance department in a company, they have specific processes and it needs to work explicitly this way. And there is no tool out there that does it exactly as their processes define. Sometimes the governance department can also force them in, let's build it themselves. So it's kind of, I've seen all kind of mixes and all kinds of reasons why companies actually decide to build or buy themselves. Mostly when they buy it themselves, build it themselves, it doesn't always end up as they expected it to be. But yeah, we'll talk about that later.
Yeah, it's something I want to immediately pick. And if I read between the lines, I think you've seen a lot of companies willing to build actually the data platform. And then your final remark goes to, there are some common pitfalls.
Yes.
Could you tell a bit about it?
Okay, so let me first discuss a little bit why there is a need for a data platform, because we're talking about something esoteric, a data platform. Is there actually a need for it? And you need data platforms if there are two conditions out there that are important to you as an organization. So first of all, you want to work with data at scale. If you just have one use case, you don't really care about scalability in a data platform. You just click around somewhere on a website or on AWS console or on Databricks and you start building your case and voila, right? A second thing that is important is self-service. Data platforms are very valuable where you offer the capability to others to build their own data use cases. So the self-service aspect is also there. And if one of both conditions are not important to you, then yeah, you don't need a data platform. But the moment you start thinking about scale and self-service, it immediately starts raising a lot of questions you have to take into account. And those questions are usually not very clear from the beginning, and people don't know what the consequence of those things are. Like, for example, the moment you start at scale and you have like 20 projects or 50 projects working in parallel, how do you guarantee that all of those projects are nicely separated from each other, that one project does not impact the other? How can you make sure that all of them use the best development practices? Are they following all the right processes? Are all security considerations taken into account? How do you share data between different projects? So there are kind of a lot of things you have to consider. And you don't see that when you just do a proof of concept, a proof of value, you go to Databricks or something else, you just build, and it just works, right? And then it's easy to see, all right, we can scale this easily, but in the end, the answer is most probably not. Because all of those, like I like to call them, non-functional requirements, they get forgotten. And those are the ones that actually decide whether your platform will break or make it
or scale.
Maybe you already told this one platform to rule everything. We decided not to take it partially due to cost, and then you ended up with a Microsoft-based data platform that has Conveyor as a cornerstone, where you still tie some elements together. Did you choose for these types of data platform also to avoid some of the pitfalls Kristof is describing, or is there more to it?
We tried it out, Databricks, and so we started by having a proof of concept, a minimum viable product, something around the maintenance management in our clean rooms, reports. We set it up in Databricks, and it was pretty expensive to start with. Databricks comes with a big license, so that was one aspect of it. In general, we have four important principles. So we buy whenever it's efficient. We build whenever it's where we make to make a difference, or where there's no option of buying, and when there is too high cost, for example. We want to achieve a modular architecture so that we can evolve towards the future, that we have modules that we can take out and put in new ones. If you have a modular architecture, okay, that means integration. Integration typically is very expensive. We try to avoid that by using open standards. So by using open standards, we try to get modules together that work as an ecosystem out of the open standards, not out of the box, but out of the open standards, so that we don't have to integrate too much. But so it's always a balance between buying efficient and building where you're special. We looked into the Microsoft box, and there is not really a data platform end-to-end that comes out of it. So you find in Microsoft only raw building blocks. You find Azure Data Lake Store, you find Kubernetes as a compute provider, you then find Azure Data Factory if you want to do drag-drop things, you find Databricks if you want to write code. And so there are a lot of building blocks, and you have to anyway glue them together because they're not coming pre-integrated out of the box. They're now trying that with Fabric, which is a very good attempt, or conceptually a good way to go. Also there you see them work with open standards, and the Delta file format, it's an open standard, and you can use whatever compute engine you want to write it and to read it. So that's what's important for me. Bart also asked the question, avoiding major lock-in with vendors. What about Microsoft? We use those building blocks from Microsoft where you have alternatives in other cloud providers. So we use Azure Data Lake Store, which is a very raw building block. You have in Amazon S3. If we tomorrow decide that Microsoft is too expensive, doesn't work, or Amazon has better features, we just move all our files to Amazon, and based on the more or less equal compatibility of features and APIs, we can make that move without too much effort. We write things in PySpark. You can run that on Databricks. But Databricks is very good as a front end, as a notebook thing to do experimental interactive things. If you just run data pipelines, then the additional license cost of Databricks is rather heavy for something that you never look at the UI. And you pay in Databricks for the UI and also for the latest version of Spark. But okay, if it's 5% less fast, we'll take it. That it's mostly good enough for us. So that's a bit how we try to avoid. We want to buy where it's efficient, and we're not going to host our own compute cluster Kubernetes thing on premise. We don't want to set up a new storage system like Azure Data Lake Store. There it's more efficient to buy, but by keeping it modular and standardized, we make sure that we can move everything to Amazon if necessary. If you really start using things like Data Factory, then you build something, you build your logic in real drag drop. It's in the end, it's a YAML file, I think, in the back that you then have, but there is nowhere on the planet another product that you can run the same thing. If you write things in code, in Python, PySpark, that kind of things, you can much easily move it to somewhere else. So that's a bit the balance that we want to bring.
Thanks, Dennis. You were already answering the question from Bart on the screen. May I remind you, if you have any questions, feel free to pop them in the chat, so I'll get them in or ask them at the end of the webinar. Maybe you're talking about this modular approach, trying to limit the set, having a migration path in mind always. So there's some gluing together needs to be done. Can you tell us something about the time to market? How long did it take you to get this actually live in production?
Yeah, I'll paint a bit of the timeline. So I started at Imec also at the same moment that COVID started. So it was a bit of a special period. But I started together with another consultancy firm, and we started with minimum viable products, proof of concepts in Azure to build a data platform with Databricks and all that kind of things. During 2021, it went not that fluid. There were a lot of problems. It was a little bit more complex than we anticipated. And we were building something in Databricks and Azure that we didn't really feel comfortable with. By doing these things and by making architectures, we realized that we were building something that we were a bit reinventing the wheel. And we had expected that there would be a data platform out of the box from Microsoft. Well, there wasn't. So we were asking ourselves, okay, is there a better way than us now bolting it all together? So we also do a lot of consultancy firms. And so a lot came with a solution based on some Microsoft building blocks. And all of them had some form of glue to it. And some had Data Factory as a scheduling engine, and some had Airflow, and some had something else. And yeah, for us, the right fit was the product from Dataminded that was called Datafy at that point in time. So the mix of open source components, the glue between those open source components, and then the fact that that's then hosted for us, and then the focus on the real, the conveyor belt concept that's appealed to us. Also because we like code, we are relatively code driven. We like the flexibility of code and the open sourceness, or the openness of Python, PySpark, that kind of things. So that's why we in the end opted for Conveyor. So I think during 2021 we made that thinking process, and I think by the beginning of 2022 we then signed a contract with Dataminded, and then at that point Datafy still needed to be moved from AWS to Azure. So I think you guys did that in about 3 months. And then it was very quickly deployed in Azure, and then we could start building. So I think I checked my Steerco presentations. So I think by August 2022, we had the product in 2021, in April 2022, and then by August we had 14 use cases in production, big ones, small ones, and now we have around 60 projects. So that's our journey with the data platform.
If I leave the pre-selection part out of scope, that's 14 use cases live in just 4 months together with building the data platform. Kristof, you've been involved in multiple companies doing something like this. Is this a timeline you recognize?
Yes and no. I've seen companies where it takes years to actually get a stable platform out there where people can actually develop on. But I've also seen companies on the other end of the extreme, just like you said it was in 3 months. I've seen this also happen in a couple of weeks. And of course, every company is different, but the less constraints you have, the faster you can get, of course. And like I said, the bigger the organization, the more requirements there are from security, process, governance, IT, but also from business. It just usually takes a while to get all of the requirements clear, write them down, do a tendering process, do the investigation, and so forth. And also in the case when you build a platform yourself, you have to answer all of those questions up front, and that just takes a while. And if you just take something out of the box, and this is more or less basically what you did, you take something out of the box, and they have answers on basically all of the questions, right? So you have something for security, compliance, way of working, best practices, and so forth. In that case, you can answer most of the questions or the detailed questions later, while you're also building value. And that's kind of the big difference between the companies that take years to actually build something and months. It's just a different concept. You accept what's there, you build around those concepts, you solve the questions later instead of upfront. And doing the upfront part, I'm going to guarantee it will take you years if you're in a big organization.
4 months were also because we had a pre-trajectory where we already wrote a lot of code, so it was partly moving things to the new platform, but it's always getting acquainted to it. So
that definitely makes sense. Michael, I saw your question in the chat. I'm building up towards that, so it's definitely coming. Kristof, you've already touched before on scalability of a platform. The scalability or the need or desire to scale things later on impact the buy or build discussion?
Yes, but it also defines how you are going to work. Scalability is kind of a very broad topic because you can talk about scalability of infrastructure. That's what people usually think about. It's also about scalability of costs, amount of projects, how you can work together. But it's also scalability about knowledge because it's very hard to find engineers that know it all in data. They know the infrastructure, they know the data, they know how to build pipelines, they know how to work with SQL, dashboards, and all these kind of things. So I think the biggest scaling problem is the knowledge. And I think it's very hard to find the right people with the knowledge to be able to do that part. So one way that you can solve your data platform is literally giving every data use case team their own AWS account. That could be a very simple way on how to scale, right? Or Azure account. But you immediately see where the problems will be. I've seen companies that actually do that, and they will end up in an operational nightmare. I've also seen where they said this is the whole core platform, everything is central, and then basically it boils down that one central team will take care of it all. So as always, the truth is somewhere in the middle. There is not always a clear answer on that, but all companies struggle in a different way on how to deal with scalability.
And you were talking about enabling 5,000 researchers. So scalability was also a concern for Imec?
Yeah, absolutely. Speed is certainly also a concern to really catch up and make sure that we have the right things available. So that's why buying is also important for us, that we didn't have to build a whole platform, that we as fast as possible can provide something to a community. So you can say, hey, if you want to do data engineering, this is the best practices. These are the standards, guidelines. So that's speed. Of course, you need the people to make that happen. So yeah, buying people from Dataminded helps us very much. We're also looking into hiring data engineers ourselves, but it's more complicated. It's also a growing phase for Imec leadership to get to know what data is, what its importance is. So at this point, we're more in a kind of project mode, and we're trying to transition to the phase where we have a solid data platform team. There is still some building involved, of course. So the DataFi part is a product, how we structure data around it, how we set up. We have one subscription, then resource group per domains. In those resource group, there is an Azure Data Lake store. How that's structured and Terraform together, that's of course still a build part. And then, okay, how do we apply standard guidelines? Is also something that the data platform provides on top of the products that we buy, of course.
We're also touching more and more upon the people. When you were addressing people, Kristof was referring to the internal knowledge to be built. I'm guessing selecting or choosing a modular approach with Conveyor there somewhere in the middle also impacts the need of skills you have internally in your organization. Probably different within your platform team and your end users. So what are the skills needed at Imec?
We are now actually making the split between a data team, platform team, and then the real data engineers. So yeah, we have now a couple of people that we're really dedicating to the platform concepts, because up till now everybody had done platform in between the soup and the potatoes. So by giving people really dedicated time on that, it's a real thing that can become a product in itself. Was that your question?
Yeah, if I also hear you talking, we're starting with a small platform team, then you were talking about this many of data users. If I hear this, it seems like you're getting towards, I want to liberate as much as people to work on value added, and I know needs to be a small team that actually enables that.
Yeah, so that's the role that we see for IT, and having the platform standards, guidelines available for everyone. And then we have a group of data engineers that can do projects, but conceptually we always give them to the individual domains to then do their thing in their domain. We want to make domains as much as possible responsible for their data, how the data is modeled. It typically starts with they have somebody that can do Power BI, and then they need data. Then we give them a data engineer to make a nice data model pipeline to get data transformed. And then together with that, we try to install a bit of ownership. Now you have to make sure that you make here the descriptions in the data catalog, that kind of things. But we encourage them as much as possible to do the things themselves. The reporting in Power BI is a good example that goes quite well. But of course, data is always a bit harder than just the nice shiny dashboard. So for that complicated part, we as an IT team support them by giving them people, by giving them knowledge, by reviewing things, architecting things. So it's finding that balance between having self-service and a lot of people in the business and having a central team supporting them.
Yeah. You mentioned it's balancing someone setting up the self-service platform, others really using it, probably liberating them as much as possible to actually focus on the value creation. Is this balancing effort something you recognize as well in other companies? Is this a phase where companies are moving towards?
Yeah, definitely. And the more the need for scalability pops up, the more that, like I said, the need for data platforms come to mind. But at the same time, those data platforms are usually owned by IT and IT departments, and IT are considered as costs. And business and departments working with the data are considered as value. So So there is always a push for organizations to spend as little resources as possible on IT and as much on the value side. And enabling this kind of a self-service pattern makes it way more easier, because business needs to do their own business case, and if they want to put the people around it, that's fine. And if you can put the IT costs as low as possible, that's ideal, right? So what I usually try to aim for, and I always try to explain it like this, I'm a big fan of what you might call the shared responsibility model. So AWS is the one that really focuses a lot on it. The cloud provider has their infrastructure about responsibilities about the compute and the VMs and all that kind of stuff. The data platform will have some kind of responsibility on making the data available, shareable, give you separation, best practices, and all these kind of things. And then you have the use case teams that just need to focus on the data and their use case, making use of the platform. And all of them will have some kind of a handover point. Like, for example, use case teams shouldn't care about infrastructure. They shouldn't care about the nitty-gritty data access, permission management, and so forth. So that's what the data platform should look like. But if something is wrong with your data pipeline and your codes, of course, the business teams need to take a look at it. We might warn you something is wrong, but it's your responsibility to take care of that. And that kind of a model is usually also a shift in how organizations have to look at data and data departments. But this really works. So I'm a really big fan of this shared responsibility model in a self-service way. With relatively small data platform teams that offer those capabilities to the end users to keep costs down and value high. That's.
But I'm going to try to get two of the questions from the chat in. They're closely linked to each other. We're now talking about scalability to business teams, as in multiple business teams. So isn't it enough to have just one large Synapse database, for example, or do you really want to have separate environments per team? And if so, if you really want to have kind of a federated approach, To go to the question of Quinten, is Conveyor designed to that? How do you cope with access policies or other elements?
That's a good question. We have one subscription in Azure, and every domain has its own resource group and has its own resources. And that's the first level of managing access. So HR, people of HR, we have a data engineering HR group. Okay, they get access to all the HR resources in the resource group. That's the first level. And then the second level is the project level. So within HR, you can do several projects. And Conveyor allows for, on that project level, also to do access control. So you can give people purpose-based access to one project. That project that can get them access to the resources that project has access to. In Azure Data Lake Store, you have the same two concepts. You have two concepts that align with that, and so you have the storage accounts, which then contains containers, and then your data is in the containers. So the accounts, so the domains have accounts in the resource group, and then on project level you can work with containers. So that nicely aligns, and so we manage that access in Terraform. We can configure both on the domain level, and then if necessary we can discriminate between different projects who has access to which data. And it's always, that's a nice built-in capability of Conveyor. You give people access to projects, and then the service principle with which the project runs, with which the notebook and the pipelines execute, they get access to the data. And so we manage then security groups. The security groups get access to the projects and the resources in Azure. And then the business people manage the content of those resource groups. So we have the data engineering, the HR data engineering group. Okay, HR can choose who has access to that, is part of that group, or the cornerstone or the core sub-success factors model or whatever projects. We can then again make security groups where they can manage the access.
Yeah, maybe to continue with the question of Michael, you really say there's not really an impact on storage. I hear you talking mostly about separating compute, really setting up in a project governance so that people can elaborate on projects. That's the scalability we're talking about, not necessarily where your data is stored.
Yeah. So yeah, we have a Synapse workspace per domain. And then we have the data platform provides a generic approach to Synapse, a Terraform concept where you say, okay, this is what I need. These tables, the templates provided by the platform team, and then the individual domain teams, they fill it in with, okay, I need these tables to be available in my Synapse schema or my Synapse instance. Depends a bit on the resource which you work with one shared thing with individual schemas, for example, in a database, or with different databases or with different instances. So I think we have a Synapse workspace for each domain. We have separate storage containers for each domain, and we keep that manageable by having common Terraform models and common practices around how you set those things up and how you maintain them.
Yeah, let's circle back a bit to the original discussion. Why you should not build your own data platform. If I listen around, people are saying I want to build my own data platform because it allows me to really innovate, to choose whatever I want. If I hear you talking, the modular approach is a bit in that direction. How does Imec see this continuous innovation, and doesn't selecting a large tool somewhere within your landscape put too much dependencies on such a platform partner?
Our researchers like to be free, and I also want them to be free, so I'm never going to, we will never enforce them to use a certain platform or product, because they will only resist that. The way we want to approach it is, if you're looking for a paved road, then we provide you one. If you not yet have something, this is how we envision it to do. And there are a lot of people that are really looking for that, because they understand that by inventing it all themselves, you have no scalability, you have operational risk, you have security risk. And a lot of people have been doing things, been trying it out, and have been hitting those things, those problems, and really like that there is now a central approach to data engineering, data science. The data engineering is worked out nicely, Power BI is worked out nicely, the other components still need to follow. But then there is a lot of demand from researchers to really get help with working, and we do that by making good documentation, by making people available to answer their questions, by really being there for them. And so if you do that, they are very likely to adopt and to use what we provide. Sometimes people see standardization as a limiting factor. I always see it more as an enabler. If you work on you can say it's a standard and everybody has to adhere to it, and then it's rigid and solid. For me, it's like a common basis to then deliver value on the next level. It's like, if we all store our data in our own formats, then it's very hard to get to each other's data and use it. If we all say it's all in Delta formatted and these are the rules, and this is how you structure your file paths and you publish it to the data catalog, then you can find each other's things, and you can very easily, with common libraries, connect to the data, use it. So it's limiting, but it's also enabling. So that's the balance.
Another key point are costs. Thinking about your timeline, selecting Conveyor 2022, so you're 2 years down the road. You have a view on cost. Can you share something both with regards to platform as to people?
So at this point, I have a data team altogether of about 15, 20 people. So it's partly data engineers, I think 8 data engineers, and some people that do more Power BI reporting, then some architects, service owner. So that's a bit the central data team. So some people work on more platform related things. Some people work on real projects for domains. We see also that domains more and more get their own people. And in the end, there are hundreds to thousands of people at Imec working on data. And they're now more and more connecting to us to get to leverage the common platforms. We're still in the preparation phase to really make a lot of publicity for it, because we're still finalizing the standards, guidelines, that kind of things to really scale. But I hope at a certain to very, very near in the future, make more publicity for it and get more people enthusiastic about it.
Yeah. From a cost perspective, Kristof, you've seen both build or buy at customers. Can you share your insights, please?
Companies do not always take rational decisions when it comes to costs. I'll give an example. So, in many cases, companies have very rigid procurement processes that can sometimes take years. There are tenders, there needs to be preparation for all of these kind of things. And it just takes a while. And it's sometimes way easier to just ask for consultancy or additional people to work on a project than to go through the pain of a consultancy, or through the pain of going through the product procurement process. And when you just think about it. So imagine you buy a data platform off the shelf. I'm just saying something. It costs 200,000 euros a year. I'm just making up a number, right? It's sometimes easier to do that or get that through than hiring 5 engineers to build a data platform yourself, which costs a multiple of that number. And that's what I'm trying to say. companies do not always take rational decisions. It's harder to get a product in a company than people in a company. And that's also one of the reasons and tendencies that I see companies building data platforms themselves, just because they believe it's easier. And at start, they're probably right, because you can get something up and running pretty fast. But just after a while, you just get bogged down in operational problems. Your team need to grow and so forth. I've seen companies starting on data platforms that start with 4 or 5 people and then make something great. But it evolves, and then they need to add new features, and then they don't think about, but all the stuff which is already there, we need to migrate it. That also costs a lot of money. And to make sure that all of that happens, I've seen teams grow from 3 to 4 people to 50, 60 people just to get the operational burden in line and also allow for new functionality. This is a cost you don't see up front. And it's also hard to, once you're in that situation, to move away. So I would like to just caution for the fact of, if you build something yourself, you might not know yet where you're getting yourself into. And this will become very prevalent later down the line. So yeah, I've seen both situations, so I just want to point that out.
Yeah. Now maybe over to a final technical aspect of a discussion. Security and compliance concerns that as well plays in a buy versus build decision. What have you seen, and are there large differences to actually secure and get a tool compliant, whether you buy it or build it yourself, Kristof?
How I look at this, and I started with, you have the different factions in an organization, and depending on the strength of a faction, there will be a focus on one thing or another. But if you just look at it from afar, all companies, they all want the same. They want to have speed in development, self-service data platforms. They want to be able to share data with each other in a secure way, and that the right people have ownership and governance over the data. They want best development practices. They want clear processes and descriptions of all the things that need to happen. So when you think about it, I don't know any company that doesn't want all of that, right? And there are only a couple of ways on how to do that. And if there is, or you can go into the endeavor of finding out what it might be and let it be a very iterative process, or you take something which has proven itself to work and you start from there. And I think this will have a very big impact on that. So the time that is spent on all the security and the governance parts, if you have to do this upfront all of yourself, this will be a tremendous effort. I think it's always better to start from something which is tried and proven as a starting point and adapt based on that. That would be my recommendation.
Yeah, you will always have 2 costs. It's the cost of your compute and your storage. That's a cost you will always have. There you can optimize it by sharing them and by making sure that you make every second useful. You often see people starting a notebook with a big cluster behind it, and then they're typing codes, and in the end, the cluster is running and waiting until you execute something. And then when it's executing, people are waiting for the result. And then when it's there, they again start coding, and then they send again. So that's compute that's waiting for something to do. So that's something to avoid. And that's why I like a Kubernetes cluster. That's one Kubernetes cluster. All load goes there. You scale it up and down with what you need, and you have always used all your compute to the last minutes, seconds, and then you have licenses, and so you pay licenses there where you can avoid spending the money on people, and people are very expensive. So that's why paying a license sometimes really pays off. Certainly, if it's a certainty. You get a product with specifications, with a proven track record. You can see, okay, this is what is going to bring me. Is it worth it or not? If you start building, you have the risk of not having to not taking into account all the things that you don't know about it. And then people is the third big pillar of cost. So there, I really like to work with more senior people who tend to have a smaller cost per feature compared to a lot of juniors. But okay, if you have a large team, you can't all have seniors, so that's also a difficult balance sometimes.
I'm coming to my last two questions, and they've been asked in the chat, so that's a good thing. So again, small reminder, we're almost there, so feel free to pop up your questions in the chat. The second to last was the vendor lock-in, and you've already replied to this, and we want to make sure that we can shift and so on. But the last one is something we skipped. Would you make the same decision again, also knowing, for example, with Azure Data Factory coming up? So are you happy with the choice in the past? And with new information, would you still make the same decision?
Microsoft Fabric coming up.
Yeah.
We are overall very happy with where we are. So Conveyor is something that we're very happy with, and that does for us deliver the value that we need from it. Microsoft is sometimes a good partner. We have very good contacts with local solution engineers that help us very much. If you have a problem and you need to contact support at Microsoft, that's a whole other story. It's it's a bit two-faced. They have two faces at Microsoft. We like to try things and learn from them. We are now supporting more the R&D community. We tried out Dash as a framework to make front-end applications. We tried it out. It seems to be a bit too limiting for what we need. So we're now going to refactor it to Dash. It's the same like we did with Databricks. We try it out. You do a proof of concept. You see what it brings. You list pros and cons, and then you look for alternatives if it's not good. So you're always going to have a learning phase and make mistakes and learn from them. So that's you're always going to have. So not every decision is always good, but you always take decisions in the context of where you are. And I don't have much regrets of decisions that we made.
If I try to summarize a bit the discussion, if today
the Fabric thing maybe.
Yeah, go ahead.
So they announced it. A couple of months ago. It's absolutely not finished yet, so I'm very eager to see what it will bring and what it will in actual look like. So depending on what it in the end will become, we'll see whether we will use it, but I think we will use the query engine. So we have Conveyor, data pipelines, Spark, Polars, create data, Azure Data Lake Store, Delta open source format. From there you consume, and there we already had Power BI. So to extend Power BI a bit broader to also incorporate the SQL engine and have that as a self-service place, that's certainly something we're going to explore.
Yeah. So again, if I try to summarize the discussion of today, I think if you look to culture, I've heard Kristof saying quite often it's IT wanting to build and it's one business wanting to buy, and that's more from speeding up the development. Funny enough, at Imec it's differently, where IT more has the buy culture, and that's to avoid reinventing the wheel, what happens quite often. And I really love the principle you had. You stated, build where you can. Buy where you can, but build where you can make the difference. I think that really makes sense. And then circling back to Kristof, if you then want to build something, keep in mind there's coming different hidden costs at the end.
That might be fine. So
Yeah, just saying be aware of indeed.
Yes, that's correct. But you should not just build it for the sake of it. Only build it if you feel that having this data platform is strategic to the direction of the organization. And only then I would suggest that you really build something custom to it. But if it's not, the platform itself is not strategic, I would say, use something additional.
And even there might be indeed good reasons to build something, but know that the cost is not only building, the cost is also maintaining.
The question is, are you different from other people? And typically having a platform is differentiating for all companies in the sense that you need one, but it's what you do on top of it that differentiates you. Your pipelines are your data. The fact that you run a pipeline is something that's if you have very special pipelines, then build your own data platform.
And it's like you're saying, it's trying to free up your people to actually deliver the value adding. And if building your data platform due to some custom desire is what adds value, then it definitely makes sense. But if your key value comes from the data pipelines, that's where your value should be focused.
And there was one thing that I noted still down. Focus is very important for a data engineer. Something that they came up recently. If they are too much distracted by, okay, this has broken, or here Terraform failed, or this, if you can really focus them on a project and have a paved road where you can very easily build something without hiccups, that's very valuable. If you distract them all the time with also platform work or platform hiccups or problems, that's...
Yep. I have one final remark in mind. It's I really love the modular approach you have. That's somewhere in between a build and buy. And that's to avoid reinventing the wheel as well. And that's what, again, in a different context you're saying here. You want to speed up people with a paved road, avoid reinventing the wheel, but actually being able to deliver value.
And flexible towards the future. You want to be able to, and we tried Azure Synapse. It didn't do what we expected because it was not yet compatible with an open source, with the open source Delta version that we were working with. Okay, we explored alternatives. You can have Databricks read Delta, you can have Synapse read Delta, you can have Fabric read Delta. Fabric was also not there yet, but they're getting closer.
In the meanwhile, I'll try to get the closing slide on screen. So that's here. So if you want to reach out to Conveyor, please visit our website. Next to that, I've seen we've answered all questions perfectly on time. It's exactly 1 o'clock right now. For me as well, it remains just to thank you for a very interesting discussion, both to Kristof and Wim, and I'm very happy you took the time to be here.
Thanks for having us.
And then to all the people watching the webinar as well, thanks a lot for joining. Thank you for the questions in the chat as well, and hope to see you on the next webinar.
See you. Thanks.
Bye-bye. Ciao.